Hello everyone, welcome back. Today we are going to talk about moles. Now, what is a mole? Well, a mole is not just our furry little friend over here in the corner. A mole is a word that describes a very specific number, and that number is 6.02 times 10 to the 23. Now that is a really big number. That is 602 followed by 21 zeros. So that is just almost incomprehensible how big that number is. But what does it really mean for us? Well, to start out, let's just think about it simply. If I were to ask you how much a decade is, what would you tell me? Well, you'd probably tell me that a decade is 10. What if I asked you, okay, well, how much is a century? Okay, well, you would probably tell me that a century is equal to 100. Now, what about a dozen? If I asked you how much a dozen was, well, you would tell me that it's equal to 12. So, all of these words, decade, century, dozen, they each refer to a specific number, and they always refer to that number, right? So a decade is always 10, a century is always 100, and a dozen is always 12. And the same thing, a mole is always 6.02 times 10 to the 23. So instead of always having to say, oh, I have 6.02 times 10 to the 23 of this, I can say I have 1 mole of it, right? And that just makes everything a whole lot simpler. Okay, so you might be wondering, where does that number come from? Well, it actually comes from a lad named Avogadro. And he came up with something called Avogadro's number. You see, Avogadro did a series of experiments, and he discovered that in 12 grams of carbon-12, there are 6.02 times 10 to the 23 atoms. Well, would you look at that? That is exactly what our mole is equal to. And so 12 grams of carbon-12, what that exactly means, if that's something that maybe you're not quite familiar with, that's okay. The important thing to note is that we base that number off of his experiment. But for us, 1 mole is always equal to 6.02 times 10 to the 23 things, atoms, particles, no matter what we're working with. Okay, so just to show you one more time just how big this number is, I'm just going to draw it out here below. So 1 mole, or a mole, is equal to 602 followed by 21 zeros. So that's 21 zeros. And that's a lot of zeros. So here we are. That is how big this number really is, right? And that is immense. So now we're going to talk about why exactly we might want to use a mole. Let's say we're on the beach building a sandcastle with our best friend. Now our best friend knows exactly how much sand he needs to build his perfect sandcastle, and we're going to get it for him. He tells us that he needs 100 million grains of sand for his perfect sandcastle. All right. And we know that 1 bucket of sand from our pail can hold exactly 50 million grains. So we go over there and we get him exactly 2 buckets of sand, because 2 times 50 million gives us 100 million. So we have two ways that we can talk about this. If someone asks afterwards, wow, that is an amazing sandcastle. How much sand did that take? Well, you could say it took 2 buckets of sand. Or you could say it took 100 million grains of sand. So in chemistry, the same thing applies. If someone asks, how much of that do you have? You might not say, oh, well, I have 6.02 times 10 to the 23 atoms of this compound element. You might just say, oh, I have a mole of that. And so using moles allows us to simplify chemistry while at the same time acknowledging the relationship between how much of it there actually is and the numbers that we use. So the microscopic, that's the 6.02 times 10 to the 23, and that more simple number, 1 mole, that we attribute to it in chemistry. So now that we've talked about this, let's do some example problems that actually involve chemistry so that we can see how these all tie together. Let's say that it's a hot summer's day and we're walking by this beautiful stream when we see a nugget of gold glistening in the water. We take it out and we put it on our scale, and its mass is 86.3 grams. But we want to know, how many moles of gold did we get? So it's time to introduce you now to the formula that we use to solve for moles, which is that N, which represents moles, is equal to little m, mass, over big M, molar mass. So let's just label that for you here. N is moles, which uses the unit mole, which I know is a little counterproductive. Where is the E? That is just the magic of chemistry. Hey, that rhymed. Okay, we have our mass, which has to always be in grams. And we have our molar mass, which is in the units of grams per, so that's divided, mole. All right. So what piece of information do we have here? Well, we're going to solve for moles. So this is what we're going to solve for over here. That's the piece of information we don't have. We have a mass and we have molar mass. Now, where is our molar mass? Luckily, molar mass is always written for us on the periodic table. And in the case of gold, which is represented by the chemical symbol Au, it is 196.97 grams per mole. So all we have to do is we have to put our information or substitute it into our formula. So our number of moles is equal to our mass, 86.3 grams, divided by our molar mass, which is 196.97 grams per mole. Now, if you put that in your calculator, you will get that we have about 0.6 moles of gold here. You're going to get a number that's a lot longer, but just following proper sig digs here, we are going to round it to the first decimal place. Okay, so that is our first case of working with the formula. And our formula has only 3 things in it, just mass, molar mass, and moles. So next we're going to talk about how to manipulate that formula to solve for mass or molar mass, because you might get a question where they give you the moles or they give you 2 other pieces of information and they want you to solve for the missing piece. Here we go. Now I'm going to show you how to manipulate our formula in order to isolate for mass or molar mass, depending on what the question wants. So I provided us with our default here, where moles is equal to mass times molar mass. The first thing that I like to do when manipulating for something else is I like to highlight what I actually want on its own. And in this case, I want mass on its own in order to get to this one. Well, what I always like to ask is, what is currently attached to my mass that I need to move? Well, mass is being divided by molar mass. So the opposite of division is multiplication. And so I can multiply this side by molar mass and this side by molar mass in order to isolate mass on its own. And so you get that mass is equal to molar mass times moles. And so when we don't have anything written between the two variables, that means that they are being multiplied. So that is our second form of our equation. The other thing that we could solve for is we could solve for molar mass. So again, let's highlight molar mass because that is where we are headed right now. And let's see what is attached to molar mass that I need to move. Well, currently I have my moles multiplied to my molar mass. And I want my molar mass on its own. So I can use opposite operations to divide away my moles on both sides. And that will give me my molar mass. And so my molar mass is equal to mass divided by moles. So I'm going to write down the three formulas one more time, just to be extra clear here. So we figured out that moles is equal to mass divided by molar mass. This one is given to us. We also got that mass is equal to molar mass multiplied by moles. And lastly, we saw that molar mass is equal to mass divided by moles. Now that we have these three formula, let's go on and do 3 chemistry practice problems where we solve for each of the possible unknowns. Let's go through some practice problems. I encourage you to try these problems on your own first and then check back and see if you got them right. But either way, let's go through them now. The first question says, how many moles are in 7.2 grams of CO2 gas? What I like to do when I'm solving any chemistry problem is always write down the information I'm given and what I'm looking for. The first thing that the question tells us is that we are looking for moles. It says how many moles. The other piece of information that they give us right away is the mass. They tell us that the mass is 7.2 grams. But what about the molar mass? Well, we can actually calculate the molar mass based on the formula they gave us. They told us that we have CO2. And so we can look on our periodic table and find what the molar mass of CO2 would be. Keep in mind your numbers might be slightly different than mine. But for me, I got that carbon was 12.01 grams per mole. And we have one of them. We also have 2 oxygens. Each of those are 16.00 grams per mole. Now, I know this looks like it says 20, but this is 2 oxygens. Okay. When I put those together, I get a molar mass of 44.01 grams per mole. All right, I have all the pieces of information needed to solve the problem. Okay, so the first thing that I can do is write down the formula. Well, we know that N is equal to little m over big M. All we have to do now is substitute in our values. We have 7.2 grams, and we know that that 7.2 grams is from CO2, which has a molar mass of 44.01 grams per mole. If you put that into your calculator, you will get that the amount of moles we have here is 0.16 with a whole bunch of numbers after it, but I'm not going to worry very much about sig digs right now. And so remember that when we're writing down mole, we have to remove the E. So that's our first problem right there. Our second problem says, Sally has a 0.22 mole iron ring. What is the ring's mass? Okay, well, what information did they give us? Well, they gave us the moles. They said Sally has a 0.22 mole iron ring. They also told us that we're looking for the mass. They said, what is the mass of this ring? So we know that that's our unknown. And lastly, the other piece of information they gave us is that this is an iron ring. And so iron is an element, and we can look up its molar mass. The molar mass of iron is 55.85 grams per mole. And again, your numbers might differ a little bit depending on your periodic table. Now, we know that we can't use our normal moles formula because we're not looking for moles right now. We're looking for mass. If you recall from our above manipulation, we saw that mass is equal to moles multiplied by molar mass. So let's input our numbers. Mass is equal to 0.22 moles. A good way to check if you're doing your problem right is to see if your units cancel out. Here, moles form a diagonal, and so they cancel out, and the only thing that we are left with is grams. And we see that mass is equal to 3 grams here. So we have a 12.3 gram iron ring. Our third problem. It says, what is the molar mass of a 2.04 mole mystery compound with a mass of 950 grams? As always, let's write down what we want to find and what we currently have. Well, it tells us in the problem that we are looking for molar mass, big M. So that is our unknown. What they do tell us is that we have 2.04 moles of this mystery compound, and that mystery compound has a mass of 950 grams. Now, we want to find molar mass. And if you recall from our formula manipulation, molar mass is equal to mass divided by moles. And so once you have this formula, the only thing you got to do is plop in your numbers. So here we have a mass of 950 grams. And moles is 2.04 moles. If we type that into our calculator, we'll get a molar mass of about 466 rounded grams per mole. All right. So that is an introduction to how moles work. If you have any suggestions for future videos, feel free to drop them in the comment section down below. Make sure to give this video a like. And if you enjoyed what you saw, maybe even give us a subscription. Till next time, this was Gen Z Chemistry.